Yeah. So we'll be discussing about takeaways. So far in our story, as I said, that we discussed electrolysis. It's recording, right? We discussed electrolysis of number one, molten salts. And then we'll make one chart so that we remember everything. Molten salts. So in molten salts, what did we see? We saw the metal ion, and we also saw the halide anion. The metal one is discharged at always cathode, where a reduction happens, and the halide one is discharged at the anode, where oxidation happens, OIL. Perfect. This was our first study. Okay. After that, what did we do? After that, we actually took the case of acid, or you can also say electrolysis of water. Don't just get confused on that. Second one, what did we do? On the second one, we took dilute acid, and the acid which we studied was H2SO4, right? Whenever you use the word dilute, then in your mind, you should always start thinking that there is presence of water. There is presence of water. So water will ionize into H plus and OH minus, and this particular acid will ionize to 2H plus SO4, 2 minus. I told SO4, 2 minus. And I told you that for the time being, you imagine SO4 nahi jata hai. Kyun nahi jata hai? That we will discuss today. Okay. So we said that this fellow, just try and see once again, this fellow and this fellow, they are common fellows. So finally we can break it down to, we get a H plus and we again get a OH minus, though we also get a SO3 2 minus, but this is preferred. Preferentially, we'll use the word preferentially discharged. Preferentially discharged. Okay, summary hai kal ka. So who goes where? This fellow will be going to cathode, and obviously in cathode reduction happens, and cathode is the negative electron. Positive will always get attracted to negative, and OH will be discharged at anode. Whenever OH gets discharged, means oxygen will be evolved. 1 mark question agar aapko pucha. Whenever OH gets discharged, oxygen will be evolved. Okay. Half reactions, if we see, an H plus gains an electron and forms H. Similarly, another H plus gains an electron and forms H. And then both these H combine together and give you H2. That is the hydrogen gas. Perfect. Then we do need to remember about this one. This one I said that you should remember. 4214, 4 OH minus will give you 2 H2O plus O2 plus 4 electrons. 4214. This is the reaction which is happening at anode. Out here, what does the reaction happen? Simple. The metal plus will gain an electron and will become metal, and the halide minus will lose an electron and will become halide. Okay. Now, this could have been studied as electrolysis of dilute sulfuric acid, or you study this as electrolysis of water. It means the same. Water will always break and give you 2 ions, H plus or OH minus, even if it is pure. But in the case of pure water, this ionization is very, very small, not enough to conduct electricity. So what do? You add acid. Then it is called acidified water. Acidified water will conduct, ekdam tabartor conduct karega. So electrolysis of acidified water is same as electrolysis of water, because end of the day, the two fellows who are participating in my reaction are none other than H plus and OH minus. The SO3 minus, 2 minus, or the sulfate ion, this is known as sulfate. This is known as sulfate. This one is not discharged. Sir, had I replaced this with HNO3, nitric acid, still the nitrate ion would not have been discharged. Samajh mein aaya? Clear? Today we are picking up salt solution. This was molten salt, dilute acid. Now we are picking up salt solution. Any question once again so far? Any question? No. Okay, so let's pick up salt solution today. So we pick up, electrolysis of salt solution. And in book, the salt solution that we have is that of NaCl solution. And when we call NaCl solution, means it's aqueous, means it has the presence of water in it. And this NaCl is a concentrated NaCl solution, rich solution. Okay, concentrated मतलब समझे हो ना, ज़्यादा dilution नहीं है, rich है ये. Rich means this another word that we use for a rich concentrated NaCl solution is called brine. Brine मतलब extremely namkeen pani, right? Where the concentration of salt is very high. So let's now see what will happen. NaCl, it is in aqueous mode, so it splits up into Na plus and Cl minus as the electrolyte. We also have water, and water liquid splits up as H plus and OH minus. So if you right now see, it has become far more interesting. 1, 2, 3, 4. Now it is a game of 4 people. Ultimately, we have got 2 electrodes. Who gets discharged from where, right? So I'm not drawing the diagram. I hope you understand. So I'm just writing here. I have cathode and I have anode. Okay. Anode is my positive here. Cathode is my negative because I'm talking about electrolysis. Okay. And obviously here reduction will take place and here oxidation will take place. Okay, bacha? And the electrolyte right now is NaCl solution. Means in this electrolyte, I have got Na plus, I have got H plus, I have got OH minus, and I have got Cl minus. Sorry, समझ में आ रहा है? अब कौन कहाँ जाएगा? ठीक है? Now some of the rules that we will find. The first thing is this fellow hydrogen will always be discharged. सब सीखेंगे. अभी आप just मान लो. This fellow hydrogen will be discharged. That means our fellow sodium will stay back. This will stay back. Clear? Okay. Out here we will find on the anode side we will find that Cl minus will be discharged. Gain change ho gaya abhi. This one will be discharged. And our friend hydroxide ion will stay back. Is this much clear, बच्चा? हाँ? Discharge means ये उस side में जाएगा. फिर वहाँ पे oxidation. Discharge means क्या? This is hydrogen ion is getting discharged to cathode. Cathode में क्या reaction होता है? Reduction. So it will get reduced to hydrogen. H plus. Plus means कलंक है ना? It will get reduced to hydrogen. That we will see. And then it will become hydrogen gas and bubble out. And on anode you will see chlorine bubbling out. So that's what. Discharge को देखते हैं अभी. Good. You just asked the question a little bit beforehand. Okay, discharge. So let's see the cathode discharge. So this is the cathode discharge. Let's see what is happening at cathode. At cathode, hydrogen ion will gain an electron and become hydrogen. Another hydrogen will gain an electron, become hydrogen. 2 hydrogen atoms will combine with each other and come out as hydrogen gas. ये होएगा ही होएगा. Okay. Barring 1 or 2 cases which we will see. So at cathode, hydrogen is discharged. Mind you, look at the case at the start. Okay, this is a salt solution, but there was a criteria. Brine hai ye. Concentrated salt solution hai. Solution. Like you make tang. If you, I always give this example. Suppose Nidhi invites me and makes a tang for me. To take all her revenge, she can make a concentrated tang. Peete hi gala jal gaya. That is also a solution, but made concentrated. And if you make it halka, then it's called diluted tang. Right now we are having concentrated. Concentrated. So hydrogen will be on. And let's see what is the discharge happening at the discharge that is happening at anode. So let's see this one. So at anode, we will have a Cl, and this Cl will lose its electron to become Cl. Just dekho. Chloride ion. Cl means chloride. When chloride, IDE. Okay, whenever. So this is my chloride ion. Okay, this is my chloride. I don't know why it loves to take that blue color. Okay, chloride. So chloride is losing its electron. Oxidation is loss of electron. Becomes a chlorine atom. Similarly, another chloride will lose its electron and become chlorine atom. two chlorine atoms will combine together to form chlorine gas. ठीक है, अब देखते जाइए, बड़ा इंटरेस्टिंग चीज है अभी. Now look here. As a chemist or as an industrialist, I am getting a very useful product from here, which is known as hydrogen. I'm getting hydrogen gas out here. Do you agree? Okay. I'm getting another useful gas for my plant or my industry, that is chlorine gas. Right? This is my number 2 product, hydrogen, and it is coming out as gas. These two gases have immense use in chemical industry, hydrogen as well as chlorine. दो product मिल गए मुझे. Who stays back? And hydroxide ion. Okay, these two, the Na plus combines with the OH minus and forms what? NaOH, king of base, sodium hydroxide. Sodium hydroxide. And what is sodium hydroxide? Sodium hydroxide is a base. So even if you want to check whether this is sodium hydroxide or not, now let's take some questions based on dimag. If you want to check whether it is sodium hydroxide or not in the tank, what do? You can drop an universal indicator. If it turns pink, means base. Or you take red litmus, drop it. If it turns blue, base. Or you take phenolphthalein. Phenolphthalein will always turn pink. Methyl orange turns yellow. कोई भी टेस्ट आप करके देख सकते हैं. This is also a very important product in the laboratory. This is an alkali. So this entire process in the industry is known as, when we study industrial chemistry, this is called chloralkali process. Chloralkali process. So what is chloralkali? We are learning many things together. Huh? All are easy, but very easy to learn and easy to forget. Chloralkali process is an industrial process in which brine or rich solution of sodium chloride is electrolyzed. Hydrogen is, 3 products are released: hydrogen, chlorine, and sodium hydroxide. Hydrogen gets released at cathode, chlorine gets released at anode, and sodium hydroxide gets released at, not released. It is the electrolyte that the remaining whatever the electrolyte, after the chemical reaction, the entire electrolyte became sodium hydroxide. ये 3 products हमें मिलते हैं. ठीक है, तो इसको we are going to study it from 2 perspective. One is what is the process and what does the process gives me as a yield. Then we will have to understand, we have right now what all things we have understood. What is the reaction at cathode? What is the reaction at anode? What is the reaction at the electrolyte level? And you took some assumptions, or you just agreed what I said, that hydrogen will be discharged, chlorine will be discharged. Right now I have not given you the reason why hydrogen was preferentially discharged, why chlorine was preferentially discharged. ये reason अभी भी आपको नहीं मिला है, आप सिर्फ मान के चल रहे हो, है ना? So now we will see why this was discharged, why this got discharged. Is there a mechanism in which I want, no, hydroxide should be discharged? That we will see. यहाँ तक, if anyone has any confusion, do let me know. From yesterday, the change that happened today is that we have taken a salt solution, a rich salt solution, and that of sodium chloride known as brine. When I electrolyzed it, I found that at cathode, hydrogen came out, at anode, chlorine came out, and the electrolyte that was left behind is sodium hydroxide, and I confirmed it with a litmus test or a universal indicator test or a phenolphthalein test, whatever it is, which means that out of the 4 ions that I got, there is some preferential treatment to an ion. And the word discharge means which ion travels towards the electrode. There were 2 positive ions, both should have traveled to the negative electrode, but hydrogen traveled and sodium preferred to stay back, or we'd say hydrogen was preferentially given the exit and sodium stayed back. And out here, chlorine was given the exit, and who stayed back? Hydroxide stayed back. Now we are going to study why this happened. Does this depend on something? Does the reverse also happen, or does something else also happen? Plus one unanswered question: sulfate also stayed back. Why did sulfate stay back? That answer to give. Additionally, we found that this sort of a process which we are studying as students out here is a process which is extremely useful in industrial chemistry, known as chloralkali process, because it gives me 3 important reagents of the chemical industry: hydrogen, chlorine, as well as sodium hydroxide. Ashmita madam, any doubt?
No, sir.
Looks like you are a little bit dull today. क्या हुआ? तबीयत ठीक है? जोश कम है?
Yes, yes, I'm not done there.
अरे not well जब रहते हो ना तब always take some potato wafers beside you and takes one glass of juice. अमूल बटर मिल्क एक आता है जिसको अमूल छाछ बोलते हैं, ग्रीन कलर बॉटल.
Yes.
उसमें कोई खराबी नहीं है, उसको आप आराम से. I'm not saying the white color one which has got rose flavor, that's extremely sweet. You take the Amul green wala and take some, not those high end Pringles, just take the simple polythene packet में जो yellow annual day chips रहता है ना, which is given in school. Take annual day chips. I keep a stock of that. टुक टक चलेगा, ठीक है. चले आगे. Now we'll see what is the preferential treatment. Okay. For this, what I'll do, I'll not take out this. Let me make this small and keep it so that this picture doesn't go away from your mind, which is known as mind. इसको रहने दो. ये कहानी यहीं पे इतना. Let this be here so that you don't forget about it. And let's circle it. I'll put this into some sort of. ठीक है, इसको याद रहने देते हैं. अब देखते हैं. Now, our first thing we'll discuss is the cathode discharge. Cathode discharge. If you have a positive ion A and a positive ion B, like in my case, I had sodium ion and hydrogen ion. ठीक है, अब पहले लिखो मत. I'll give you time to write. First, enjoy the story. Chemistry is like literature. You have to first enjoy, then you'll get. I'll give you time to write. पहले समझो. Out of A and B, the rule is the more reactive stays back. This brings us to our whole story of the reactivity series of metals. Please stop calling me a zebra, caring zebra. Carbon भी घुसाते हैं हम. Instead, try learning how copper saves gold. Remember that? नहीं तो फिर से लिख लो. Please, आपको लिखने की जरूरत नहीं, आप सिर्फ मजा लो इसका. Stop calling me a caring zebra. Instead, try learning. One minute. Instead, try learning how copper saves gold. Which means this gives me my element. P stands for potassium, K, stop, sodium, Na, calling, calcium, Me, magnesium, A, aluminium. This one I'm writing this side because this is a non-metal carbon. Why I have brought this, that also I'll tell you. Zebra stands for zinc. Instead stands for iron. Tri stands for tin. Learning stands for lead. How? Again, I'm bringing this side because this is a non-metal, hydrogen. Copper is copper, saves silver for argentum, and gold is Au. Now look out here. What you need to be very careful in this whole discussion is you need to keep your eyes fed on hydrogen. Sodium was more reactive than hydrogen. The more reactive stays back. The more reactive stays back. Have you understood? So, have you got your answer? In our discussion, we had sodium versus hydrogen. So, sodium being more reactive, this one stays back. And this one gets discharged. Are we fine or not? Now let's put this story into each of the case. The first case was molten salt. In molten salt, there was no competition. There was only one metal ion. Please go. Second one, we had dilute acid. We had H plus from water, H plus from acid. Same clan. Please go. In the third one, we had H plus and Na plus. So what did we say? Na plus, you're going to stay back. H plus, you move. Clear ho gaya? Okay. Now we're going to see what happens at the anode discharge. In anode, the story is all about concentration. The story is concentration. If you have halide, what is a halide? Chlorine, fluorine, or bromide, all these are halides. If you have a halide and if the concentration is high, then the halide is preferentially discharged. Wow, what a story. It is preferentially discharged. What did we take in our third case? Concentrated solution of salt. Chlorine ka concentration zyada tha, so chlorine got discharged. Are you clear now? In our case, chlorine got discharged. Chlorine got discharged. Let's again go case by case. Case number 1, we had molten salt, only one anion, so discharged. Case number 2, we had OH minus as well as SO3 2 minus. SO3 2 minus did not get discharged. That I am yet to tell you. In case number 3, we had OH minus, Cl minus. Since the solution was rich in chloride ion, so chloride ion gets discharged in the form of chlorine gas. Now your next question should be, sir, if we would have not taken a rich solution of sodium chloride and taken a dilute solution of sodium chloride, then what will happen? यहाँ पे कोई change नहीं होगा. Whether you take dilute or strong, sodium is still more reactive than hydrogen. So hydrogen only will go out. Is it getting clear now? But यहाँ change हो जाएगा. If you take dilute, then OH minus will make the exit. So OH minus exit means you will see oxygen coming out. Chlorine is a yellow gas. So sometimes they might make this question very elaborative to you. They might tell you, are you using a strong solution of acid or a weak solution? If they say that the gas which is evolving is yellow in color, that means it's chlorine, oxygen. The gas which evolved, okay, is a supporter of combustion. Oh, oxygen is getting released. That means a dilute salt solution is being electrolyzed. Are we clear on that? Okay, we'll see that also. Just abhi samjhiye isko. Now we are still not answered on SO3. So if I make a progress chart out here, what will I see? I will see that if you have, say, sodium plus, right, or if you, they're all much more reactive than hydrogen. Anything which is more reactive than hydrogen, then hydrogen will be released. As simple as that. Here there is another story. The story says that if you have an anion like SO3 minus, that is 2 minus, or you have something like, or you have, one minute, or you have NO3 minus. In both these cases, the OH minus or the Cl minus will actually precede them in discharge. SO3 and NO3 do not get preference in discharge. Let us understand once again. If I am a strong solution, then anyway, based on concentration, chlorine gets discharged. SO3 ka patta to kat gaya. Had the acid been nitric acid, nitrate ka patta kat gaya. Had it been a weak solution, then this one goes away. Inka kabhi koi pasta nahi. Yes. I didn't get you. Your voice is coming broken, beta. Use a headphone. Do you have a wired headphone with you? Oh, SO4. Yeah. SO4. Okay. Sorry. I'm sorry. Wow. Thank you. SO4 2 minus. Yeah. A sulfate or a nitrate never gets discharged. It will always be the halide or the hydroxide. Is this thing understood? Based on this, we'll take some more iterations now. Okay. Now my next iteration is, if I had taken dilute NaCl solution, try to understand the difference. Concentrated NaCl solution, dilute NaCl solution. If I take dilute NaCl solution, then let's see once again, cathode, anode. Let's see who are our players. Our players would be Na plus, H plus, then Cl minus, OH minus. We are taking dilute NaCl solution, not the concentrated one. So हमें यहाँ पे क्या देखने को मिलेगा? We are going to see H plus getting discharged at cathode and OH minus getting discharged at anode. How the reactions will be? H plus will again gain an electron and become H Another H plus will gain an electron, become H. 2H will combine together to give you H2, and this is what is getting discharged. What will be the reaction on this side? Again, 4-2-1-4 reaction. 4OH minus will convert to 2H2O plus O2 plus 4 electron. 4-2-1-4. इसको आप भूल ही नहीं सकते. जहां जहां hydroxide will get discharged, the reaction is 4-2-1-4. Write it 3-4 times, gets registered. Have you understood? Yeah.
Like sodium is like
More reactive. More reactive means it will immediately react with the ion that is present. See, you and your sister, say both are of the same age group. You are more fighter by nature, right? If there is a piece of cake, who will go and eat it first? You. So the piece of cake is OH. Sodium immediately goes and combines with OH. But in this case, we have to understand this case. Okay, let this. So, yes, 1 minute, just 1 minute.
Nice.
In this case, hydrogen went away, right? Sodium has stayed back. Hydroxide has gone away in the form of oxygen. Who stayed back? Chlorine has stayed back. So the solution still continues to be dilute NaCl. Are you getting it? This is not chloralkali process. This was chloralkali. Chloralkali mein jo reh jayega, that is NaOH. Here NaCl is remaining. NaCl is just a dilute solution. Solution है ना, solid क्यों होगा? हाँ, what solid में तो कभी react ही नहीं करेगा. Why are you getting it wrong? But still there will be hydroxide left ना. The NaCl last में जो रह जाएगा, it is still NaCl. NaCl in aqueous form रहेगा. So what we are trying to say is that you will have a hydrogen discharge here, you will have a chlorine. Yes, Ashmita, your question. Before we go ahead. Yeah.
Yes. So I need to know that phosphorus was discharged in the anode for like a dilute solution.
Because we said that anode discharge depends on this parameter called concentration. If you have a halide,
Yes.
that is Cl minus, and its concentration is high, then the halide is preferentially discharged. Here you had a halide, Cl minus. Concentration was more, so it got discharged. In this, हाँ here ये तो dilute लिया ना, लिखी तो दिया. ये वाला, this was brine, this was dilute. ये एकदम, that's what that निधि वाला example I gave. This was that गला जलने वाला tang. This is आराम वाला tang.
Oh, okay, so that's it.
हाँ, this chapter में everything is easy, but a lot of things are spread on the table. अभी एक और चीज देखना है आपको. निस्मत समझ में आया?
Yeah. So because Cl did not be discharged because it's weaker in the center because it's a dilute solution.
Because the concentration of Cl is less. Whenever the concentration of the halide will fall, the hydroxide ion will take the advantage of getting out. Once again, listen to me. The positive ions में the more reactive stays back. खत्म बात. और generally आप देखो, अगर आप इस चार्ट को देखो, जितने सारे metals हैं वो सब हाइड्रोजन के ऊपर हैं. तो ज्यादातर चांस में हाइड्रोजन ही बाहर जाएगा, मेटल तो रह जाएगा. Have you understood? Come to the anode side. Anode you will always have a halide, or you will have a hydroxide, or you can have a hydroxide and a sulfate, or a hydroxide and a nitrate. Sulfate and nitrate are पैदाइशी किस्मत का फूटा. They can never go away.
Yeah.
So competition now is between hydroxide and chloride, halide. If the concentration of the halide is more, bhai sahab, please go out. And if the concentration is less, you stay back. And the hydroxide ion goes. Another thing that you should remember, hydroxide getting discharged means hydroxide does not go out as a gas. Oxygen goes out as a gas. बड़ा सुंदर चीज है. Here,
Yes.
hydrogen gets released means hydrogen gas will go out. Proof, इधर ध्यान दे, मैं बार बार बोलता हूँ. सुनने के बाद, वीडियो देखने के बाद आप किताब देखो, उसमें 2-3 चीजें मैं मिस भी किया तो भी बोलो. यहाँ जरूरत है, अगर आप उसको डायरेक्ट पढ़ पाते तो एक आदमी के समझाने की जरूरत नहीं पड़ती. पहले सुनिए, क्योंकि अभी क्या होगा ना, तुम उसको पढ़ के प्रेजुडिस्ड हो जाओगे. Please read it thoroughly after the class is over and make sure whether you have understood. If not, keep it. Okay, what I was saying, here always hydrogen is going out. as a gas. Hydroxide never goes out as a gas. Oxygen goes out as a gas. Are we clear? Because now I'll rub the board
Yeah.
and I'll write something more now. Okay. Okay. Do you want time to write anything? You have time. 1 minute or anyways, this class is getting recorded. So 1 minute strategic timeout if you want to write something. Your takeaway. When you go back home, try to listen to the video once again. The video does not mean that this video was there because I did not miss the class. Why should I see the video? A 1 hour video will take 2 hours to study. Start, stop. Write down your notes and then parallelly read your textbook and then see whether there is something in the textbook I did not teach or I missed out or you did not understand. Then bring it to my notice. समझा? तो किताब बंद कर सबसे पहले. हाँ, ऐसे किताब नहीं लाता है. ध्यान दे. मैं जरूरत से ज्यादा ही पढ़ाऊंगा, कम नहीं पढ़ाऊंगा. And that OH minus reaction, try to write on your own. 2 बार लिखो. Close your eyes and write. 4OH minus gives you 2H2O plus O2 plus 4 electrons. Yeah. And when you'll say that you're done, then we'll go. Half an hour gone. बाकी half an hour में 2 और चीज पढ़ना है. जल्दी गाड़ी बढ़ाइए. And don't write with red pens. Red is the weakest color to be picked up by the human eye. Red is only for important writing. Write with a black or blue. You're writing everything with red. Is everything important? Reactivity series उतना में red में नहीं लिखते. पहले blue को लिखो और इसको साली red में लिखो. जो चीज आंख में पढ़ना चाहिए. हाँ. इन क्रूड सेंस, कल जब एक झुंड में तुम्हारा एक गर्लफ्रेंड हुआ ना, वो रेड है. इंपॉर्टेंट वाला चीज, बाकी चीज नहीं. समझ में आया? हाँ, कीर्तन को देखो, व्हाट अ लाफ, ही इज एंजॉयिंग. Ahiri madam, all okay?
Yes, sir.
All like that? चले आगे, shall we?
Yes, sir.
Okay, anyways, you're getting it recorded. चलेगा, चलेगा. नहीं तो खत्म नहीं होगा. आइए. So we go back to our brine, and in our brine, let us write the equations once again, show the complete equation. So half reactions once again we'll see the half reactions at cathode. This is for the concentrated NaCl solution. Again, it's writing in green. 1 minute, children. Okay, we're talking about concentrated NaCl solution. So at cathode, we'll now see how 2 half reactions can be combined. So at cathode, what is happening? H plus takes an electron and becomes H. I'm just writing one equation out of it. Okay. H plus takes an electron and becomes H. Okay. And then another H plus takes an electron and becomes another H. If we add these two, we get 2H plus takes 2 electrons, and you basically get 2H, or you can write H2. Okay, understood? Now at anode, please concentrate on this reaction only. Similarly, at anode, I'm having Cl minus, which becomes Cl and releases 1 electron. This is that 1 electron. यही वो electron है जो इसको खाया. ठीक है ना? Cl minus. And I hope you are fine with the electron story. I told yesterday, the electrons are deposited in the electrodes. From the electrodes, they go back to the circuit, and the battery again pushes from one terminal to the other. And in the electrolyte, it is the ions who are flowing the current, right? So Cl plus electron. And if I add these two, I get 2Cl minus gives me Cl2 plus 2 electron. The concentration should be on this one, okay? अब क्या करते हैं? ये वाला जो इक्वेशन है ना, इसको कर लेते हैं रेप्लिकेट और यहाँ ले चलते हैं. ठीक है? And this particular equation will replicate this one also, and we'll take it here. ये दो इक्वेशन हुए हमारे, right? Fine. And आई थिंक ये थोड़ा ज्यादा आ गया. 1 minute. These two equations we have got, and there was another one equation which was NaCl had split up to Na plus Cl minus. ओरिजिनल NaCl आया था ना, वो भी तो है ना. So and you can write it as 2 NaCl. So 1 minute. 2 NaCl, 2 Na plus, 2 Cl minus. 2 to 2. I have done all 2 to 2 because in that case ये वाले हमारे मैच हो जाते हैं, right? Now if you add up all reactions, then you will find if you add these two reactions, this 2 electron will cancel these 2 electron. Clear? ये इस side है. So and Na plus, this should give you NaCl. So finally our reaction is something like this. NaCl was something that you used. Then you used H2O. What did you get? H2. And you got Cl2. And you got NaOH. These are the three products. इसको balance कर लेते हैं. 2 of hydrogen, 2 of hydrogen, 2 of chlorine. So we take 2 of chlorine. If we get 2 of chlorine, sodium has become 2. इसको भी 2 कर लो. और फिर 2 to 2, hydrogen 2. Hydrogen has become 2 plus 2, 4. So make it 2. I think now it's balanced. This is the final chloralkali process. NaCl reacts with 2H2O to give you H2Cl2 this. Okay, understood? Right. Now, one more interesting thing. This is nothing, this is just an extension of what we have studied. Now, let us do one interesting type of electrolysis. Let us take electrolysis of CuSO4. Okay, CuSO4, and let us take that we are taking a concentrated solution of CuSO4. Concentrated solution of CuSO4, right? CuSO4 concentrated, or concentrated लेके भी कोई फायदा नहीं होगा. It will mean the same. Let's take dilute CuSO4. We'll take concentrated also. We'll discuss. Don't worry. We'll take dilute CuSO4. Let us now see what is happening. CuSO4 aqueous will immediately split to give you Cu2 plus SO4 2 minus. And since it is a solution, you have water. Water will give you H plus and OH minus. Have you understood? So let's go back to our discussion. Cathode, and we have anode. Again, I'm writing it many times so that you understand it. एकदम दिमाग में घुस जाना चाहिए, रट्टू नहीं करना है. Cathode. Cathode means a place where reduction is happening, where oxidation is happening. In an electrolysis process, this is negative, this is positive. What are the ions we have now? Cu2 plus, then H plus, OH minus, and SO4 2 minus. चल, अब मुझे बताओ इसमें कौन डिस्चार्ज होगा? Let's take it. If you have understood here, Ashmita, you take the call. It's a dilute solution.
Yes.
Okay, so obviously the pluses are going to go to the minus side.
No.
Out of these two plus, who should go?
Sir.
No issues. That doesn't disturb me. You can speak. Yeah.
Sir, the acid side, CO2 plus will discharge.
Why CO2 plus? Why CO2 plus will discharge?
CO2 plus H plus will discharge.
Why H plus will discharge? Because you are just changing your answers.
Plus CO2 plus is less.
So less reactive means who should get discharged? I just gave an example. CO2 plus will get discharged here. Instead, try learning how copper saves gold. Had it been copper, had it been silver, had it been gold, had it been platinum, in all these cases, hydrogen will get discharged. That's the rhyme. Like, please stop calling me a zebra. Instead, try learning how copper saves gold. नीचे platinum. तो यहाँ बड़ा interesting है. यहाँ भाई साहब ये जो copper है ना, this copper is going to get discharged. So our reaction will be Cu2 plus is going to gain 2 electrons and become Cu, and you'll see copper deposits happening. Don't write copper gas will go out, but zero milega. Copper is not a gas. Copper deposits milega. Okay. Okay, Ashmita, on the anode side, tell me. Anode is always OH minus. ये तो है ही फुटा किस्मत, पैदा ही हुआ है युगांडा में, है ना, इसका कुछ नहीं होने वाला है. So anode में क्या हो जाएगा? 4OH minus. Again, see, I'm writing so many times. 2H2O plus O2 plus 4 electron minus. That means don't say OH minus. OH minus will be discharged to the electrode and finally oxygen gas will be evolved. वो गलती. Don't write OH will be evolved. Oxygen gas will be evolved. So if you take copper sulfate, copper जाएगा. ठीक है? यहाँ खत्म होता है all the three type of salts that you studied. I think I have covered it in enough detail. Molten salt, dilute acid or water, and then concentrated salt solution, dilute salt solution. Hope you remember everything. At the end of the chapter, before we go, we'll make one final matrix again to understand. Let's now go to one more applications of these particular type of things. Okay, shall I rub this? Okay, we need to now understand one process which is known as, ये सब एकदम छोटा छोटा है, electroplating. Electroplating. Now what is electroplating? The process of depositing anything that you have a doubt, you can tell me, I'll tell you. Any reaction doubt? Okay, electroplating, a process in which a desired material or a desired grade 8 students writes material. Good. Do you know? A desired metal layer is coated over another metal. It's called electroplating. Why do you do it? Two prime reasons: look, finish, and protection from corrosion. This is very common with you girls. You wear jewelries which are electroplated jewelries. Okay, electroplated jewelries means they will have electroplating, plating of gold, not completely gold. So it gives you a rich and premium look. Have you seen the logos of car right at the engine spot? Those logos are all electroplated with chromium. And if you go to high class restaurants and hotels, you see those Jaguar and Polar taps. So Jaguar taps and all are electroplated with chromium. Chromium is very costly, but chromium gives a very premium and rich look finish. Okay, और ये costly होगा. The car invests a lot. The brand will always invest on its logo. पूरा गाड़ी में भी अगर rust हो गया ना, that logo will never rust. In fact, people pilfer logos from cars also. Mercedes का जो logo है ना, वो काफी costly होता है. So people pilfer and melt it and sell it thinking that it is, but they are all chromium plated. We say it chrome plated. Even in cars, like on the back side, if you see VXI, LXI written, all those will be chrome plated, chrome finish grill. So the job of electroplating is that I will have one metal object and I will electroplate it with another metal. Usually what do you electroplate with? Gold, silver, platinum, copper. These we use for electroplating. Primary job is to have a rich look, premium look, used for jewelry and also for protection against corrosion. They give you a long life. In this electroplating, if you see your spoons, okay, the spoons that are served in your say up class restaurants, and you say that they are silverware, you say silver cutlery. Silver नहीं होता है वो, उसको हम बोलते हैं EPNS. EPNS cutleries are more costly and looks very premium. EPNS means electroplated nickel silver. लिख लो, ये syllabus में है. Electroplated nickel silver. But the irony is that, my friend, there is no silver in this alloy. You only have copper, zinc, and nickel. It's an alloy of copper, zinc, and nickel, and it is highly used in up-class cutleries, forks, fruit spoons, serving spoons, table spoons. They will all written EPNS cutlery. EPNS मतलब shine करते रहेगा सर. Electroplated nickel silver, but no silver is present. Copper, zinc and nickel are present. समझ में आया? चलो, अब थोड़ा सा देख लेते हैं electroplating कैसे किया जा सकता है. How to do this electroplating? As you write, let me make it. So whenever you want to electroplate, let's say I want to electroplate a spoon. I want to, or a ladle, as we say. Ladle समझते हो ना? With which you take out sambar. That's for a ladle. So I want to electroplate my ladle, and I want to electroplate it with copper. right? So the object which is to be electroplated, now again pay attention here and drop your pen. See, the object which is to be electroplated, what do I want it to be electroplated with? Copper. Now you are in the chapter of electrochemistry. Copper se to paint to nahi karenge. Copper ions have to go and get deposited on it. What are copper ions usually by their nature? Cu2 plus. Plus वाला किसकी तरफ जाएगा? माइनस की तरफ जाएगा. एनोड वोनोड मत बोलो, प्लस वाला माइनस की तरफ जाएगा. That means this one has to be connected to the negative terminal. As simple as that. And the metal with which you will electroplate, that is this is a strip of pure copper. So pure copper with which I'll electroplate. Obviously, I will connect this one to what you call the positive side. Done. Okay, the first thing is, so these are the points you should remember. Object to be, because true or false mein aa jayega, object to be electroplated is always made negative. And this is the process of electrolysis again. Negative means cathode. Negative means cathode. Reduction has to happen, na? Cu2 plus means what? They are having kalank on their head. Cu2 plus, you don't like it, you like Cu. So that 2 plus has to go away. The reduction will happen here. They will be discharged on this side, okay? And this will become my anode. Another thing you have to take care is the electrolyte has to be a salt of the metal that you want to electroplate. CuSO4 has to be a salt of the metal whose layer has to be put. Iron spoon, I want to give it a copper look. So I'm using pure copper. This is pure copper as my anode. And the salt has to be a salt of this particular metal. So kya use karenge? Copper sulfate. Had I wanted to do it with silver, I may use silver nitrate also. But you can't use copper and silver out here. तब गड़बड़ हो जाएगा लेकिन. ठीक है? अब देखते हैं reaction होता क्या है. Usually what happens, CuSO4 as my electrolyte will get split into Cu2 plus and SO4 2 minus. SO4 2 minus का तो तुम्हें पता ही है, फूटा किस्मत है. This is all known as a spectator ion. खाली बैठ के तमाशा देखता है. In fact, we call them as spectator ion. यहाँ पे क्या reaction होगा? So at anode, always oxidation happens. So Cu becomes Cu2 plus and loses 2 electrons. This is at anode. मजेदार चीज है, हाँ. This is oxidation. Oxidation is OIL, loss of electrons. ये create हो गया Cu2 plus. Now people generally think that these Cu2 plus actually go and travel here. Again, something interesting. Observe properly. These Cu2 plus go and travel here. These Cu2 plus go and travel here actually. उसका beauty भी समझ में आएगा. I am going to the shop and you gave me 5 rupees. Sir, आते वक्त एक पेन खरीद के लाइएगा. I kept your 5 rupees in this pocket of mine. Is it necessary for me to buy your pen with this 5 rupee note only? No. All you need is your हिसाब once I come back, if there is any change, and the pen. मैं यहाँ के 5 रुपए के नोट से वो पेन खरीदता हूँ. And why should I spend for you? Then I take your 5 rupees and I put it here. Did I lose anything in this transaction? No. Was the pen actually bought by your given 5 rupee note? No. But 5 rupees hisab is overall fine. These Cu2 plus, what happens? These Cu2 plus, electron यहाँ पे रहेगा ना. So at here, at cathode, the reaction that is happening is Cu2 plus gains 2 electron and becomes copper atoms. Got it? These copper atoms start depositing here. और यहाँ से जो depletion हो रहा है, उसको ये भरपूर कर रहा है. बड़ा interesting चीज है, देखो. These Cu2 plus are going here, and these Cu2 plus. रुको, हम आ रहे हैं. We're coming. So in the whole process, the beauty is that the electrolyte never gets used up. इसका वैसे ही बरकरार रहेगा. Electroplating की ये बड़ी खूबसूरती की चीज है. You know a fountain? A fountain gives you all the glory and beautiful to look, but the water never gets used up. The same water is coming in. If you know, वैसा ही है. So what do you need to remember in electroplating? What is electroplating as a process? The expansion of the acronym EPNS you should know. What is EPNS comprising of? You should know. What are the uses of electroplating and why do you do electroplating? So it's very simple. Premium look, rich finish, and corrosion and long lasting. That. And what is the standard process of electroplating? The metal or the object, will use the object to be electroplated, is made negative. You can't afford to forget that, because the positive ions will always go towards the negative. Isko negative banana hi hai. Rats are going to come towards the cheese. So this has to be made the cheese, right? So the metal will be made, the metal or the object to be electroplated is made negative. The pure metal whose layer you want to deposit is made as positive. That means it comprises the anode. This is still electrolysis, and this is made cathode. Reaction, what have to, and the electrolyte has to be a salt of the metal that you want to be deposited on the object. इसको और metal नहीं बोलेंगे, object बोलेंगे. क्लास 8 में सीबीएसई में एक बच्चे ने पूरा ये एक्सप्लेन करके प्रोसेस लिखा, और यहाँ पे क्या लिख दिया पता है? वुडन स्पून. बेचारे का नंबर कट गया. वुडन स्पून पे तो कभी होगा ही नहीं. You understood what mistake he did? How can you electroplate wooden spoon? It has to be a conductor, right? Then he realized. I said, very nice. See, यहाँ पे diagram बना के. I mean, I think his copy is here only. I can show that to you. Poor fellow, he did it so nicely. Now this is his copy. Very, very sincere child. Last day, see, he did electroplating and he wrote wooden spoon. And itna अच्छा लिखा, but I had to, and I said only metallic objects conduct electricity. और एक smiley face बना दिया. क्या करूं? काटना तो पड़ेगा number. ठीक है? So don't make that mistake. And the electrolyte never gets used. So what is the process? The electrolyte splits up into copper ion and sulfate ion. Sulfate is always the spectator. पैदाइशी फूटा किस्मत. These copper ions get discharged at cathode, take electrons, and then they come out as copper atoms, and these copper atoms get deposited here. In the meantime, copper atoms get ionized to copper ions and they rush to take this place, ensuring that the balance is maintained. एक लास्ट और एक प्रोसेस है, उसको भी देख लेते हैं. इस प्रोसेस को हम एक और जगह भी यूज करते हैं, सिमिलर प्रोसेस विच इज कॉल्ड प्यूरिफिकेशन. Purification of metal. Although CBS, what do you call, Cambridge has mentioned this, but they have not gone deep. But they have said like anode discharge and also. Let us understand. You know, copper when it is extracted, after copper has been extracted, you cannot get pure copper. And in electrical purposes, we need copper which is 99.9% pure. Copper's purification is always done by electrolysis. Now see how copper is electrified. इससे पहले आपको थोड़ा सा गणेश पूजा समझना पड़ेगा. What is the structure of Ganesh? Real fact. And the disciple of Ganesh is that rat. Rat is thin. Remember that. वो काम में आएगा अभी यहाँ पे. Okay. Now this is the impure copper that we have. Impure copper, which we have just brought from our blast furnace. So we have to purify it. Purify मतलब क्या है? This impure copper must be containing some impurities inside it. Either you take out the impurities or you take out the copper and let the impurities stay. Mosquito net जानते हो ना? People sleep inside a mosquito net to be away from mosquitoes. There is another way to sleep also. Keep the mosquito net open and push all the mosquitoes inside, trap them and you sleep outside. वो भी तो possible है. तो वही मैं इसमें बोल रहा हूँ. या तो इससे सारा कॉपर चूस लो या पूरा इंप्योरिटी चूस लो. सो हम यहाँ पे इलेक्ट्रोलिसिस के लिए सारा कॉपर चूसेंगे इससे. सो ऑल द कॉपर्स हैव टू गो आउट एज व्हाट? कॉपर प्लस कॉपर प्लस कॉपर प्लस. इसके लिए वी हैव टू पुट अ बेट. यू नो बेट? सो द बेट विल बी अ स्मॉल वायर व्हिच इज अगेन प्योर कॉपर. दिस इज प्योर कॉपर. एंड अगेन सिंस यू वांट कॉपर टू गेट आउट, द इलेक्ट्रोलाइट हैज टू बी कॉपर सल्फेट. समझ में आया? The first reaction, and this will be connected to, we want copper to go this side, so this has to be my negative and this has to be my positive. In other sense, this is my cathode and this is my anode. First reaction, CuSO4 becomes what? Cu2 plus SO4 2 minus. Same story. यहाँ से क्या हो रहा है? Again, these Cu plus from here immediately go and rush to this fellow. Cu2 plus gains 2 electrons from cathode and becomes Cu. Understood? So Cu, इसमें Cu ये सब डिपॉजिट होना शुरू हो गया. ये तो अकेला नहीं रह सकता है. भाई साहब मैंने आपके लिए खर्चा किया, मेरे को मेरे पैसे दो. So from here again the Cu gets oxidized to Cu2 plus 2 electron. These Cu rush to take the place out here. And why did I say that Ganesha wala example? This is because after the process has run for some time, this fat Ganesh will become thin rat, and the thin rat will become fat pure copper. सारा कॉपर यहां से इस तरफ चला गया ना. So all you will be left with what? What? Impurities. And impurities अपने आप को बांध के नहीं रख सकता है. The entire impurity will fall here. And this in chemistry is known as anode mud. Not used in IGCSE, but for knowledge you can keep it. Anode mud. The entire impurity fell out of. वहां से धप करके निकल गया. कैसे? कुल्फी और चोकोबार पीते पीते थोड़ा रह जाता है ना लास्ट में, संभल के नहीं पियोगे तो टप करके गिर जाता है. That is the chocobar mud. This is the anode mud. Clear? So what are the uses of electrolysis, electroplating and purification of metal? In purification, we will always use pure metal as the bait and the impure as the block. Copper ions from impure go to electrolyte, from an electrolyte. ऐसे धीरे 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 गणेश पतला होता जा रहा है, चूहा मोटा होता जा रहा है. That's why Ganesh engine. Perfecto. This is finished. And in the start, we have 5 minutes more. So last 5 minutes, one small topic discussion. We're over with this chapter. Okay. In the first topic, we had discussed about hydrogen fuel, hydrogen fuel, hydrogen fuel. Okay. So, अभी इसमें कुछ ज़्यादा नहीं पढ़ना है. So how is hydrogen used as a fuel? Okay. So in all these stories so far, one thing you have learned is if you have water, then you can electrolyze it to hydrogen plus oxygen. ये समझ में आया? This is liquid, this is gas, and this is gas. You are breaking something. Bendo means breaking is endothermic. So it is energy intensive process. You are supplying lot of energy. What energy? Electrical energy you are supplying. Then only this is happening. So now query comes. इसको अगर हम रिवर्स कर सकते हैं तो ये एक्सो होना चाहिए. If I can formulate a reaction which is 2H2 plus O2 and it gives me H2O as a liquid, then this process should give me a lot of electrical energy as an output. Do you agree or not? This is the guiding principle of hydrogen fuel as a fuel for vehicles. This electrical energy can be made to run the motors of the car. We don't have engines in electric cars. Electric cars have got motors in them. इसी से चला सकते हैं. यही principle है. And the what you call exhaust that you will be emitting in this process is what? Water. So good for the atmosphere. Water छोड़ छोड़ के जाते रहोगे. Problem now is that while this can be sucked from the atmosphere as the bus is moving, this has to be carried or stored. So one of the options now we have is hydrogen fuel stations, which are very less. That's why this is not becoming so successful. If we have more of hydrogen fueling station, then the energy obtained here will be much more. Now you'll ask me, sir, how are electric vehicles running right now? It's like MG, all this, Morris Garage ke jo gaadi, MG Hector. MG Hector runs not by this. MG Hector has got a battery, and with that battery it is running the motor, and the batteries are extremely costly. Government gives you extra tax benefit if you buy that car. If I have a petrol car, my road tax is more. Green cars taxes are less. This Nidhi, they have a green car. Their number plate is green. So they have a battery. In future, you can have hydrogen fuel. Hydrogen fuel buses run. They run in countries like Brazil. There are. But the question is that this is storage of hydrogen is a little bit problematic. Process is very expensive as of now. And the second part comes: is the hydrogen green? How did you manufacture this hydrogen? Did you manufacture it by using electricity which used nuclear or coal-based power plants? Then it is non-renewable. Did you make this hydrogen by using wind energy or say hydel power or say geothermal energy? Renewable. Then this hydrogen is called green. समझ में आ रहा है? मतलब मंदिर में पूजा की थाली से आरती के लिए जा रहे हो और बहुत सारा डोनेशन दे रहे हो, और वो पैसा आया कहां से? 2 नंबरी काम करके आया. So is that donation really holy? No, the same thing is happening here. ये green बोल के कुछ नहीं, green ये hydrogen green करो पहले. So the book will have two things like what is the advantage and what is disadvantage. Right now the disadvantage is this is you don't have so much of fuel station, bulky hai, so you have to carry hydrogen. Again, storage of hydrogen is a little bit problematic, but the efficiency these vehicles have is 60%. Huge efficiency. Petrol engines have only 20%, 21%. Diesel will have 38 to 39%. These have 60 to 65% efficient. Plus, the best part is the exhaust. Something that the world needs. You और ये water vapor की तरह निकलेगा, निकलने दो, कोई बात नहीं. Condensation होके बारिश होके गिरेगा. But ये कहाँ से ला रहे हो? So that's the concept of green hydrogen. Right now, the hydrogen that you are fueling in your bus is gray hydrogen. And there's a lot of research going on stock markets, all companies. This is the call of the hour. There are people, Adani Green is one company only looking for green solutions. उसके share prices और बढ़ेंगे because यही future है आगे चल के. Electric cars with battery will no more be a viable option, but this will be a viable option. And with this, we come to the end of this Rangarang Karikram. So please have now what to do. What to do?